Hi there, welcome to video 3 about slope and rate of change. You should be on the third page here as we keep going in this very important lesson for Algebra 1, as it's going to lead to a lot of things we're going to be talking about the rest of the year here. So in this particular part of the notes, what they're trying to do is their this key concept. They're trying to just show you what it is that's going on here, okay? And this looks much more complicated than it really is once you see what they're telling you here. So let me try to walk you through it. Please follow along and see if you can get what we're trying to say. So in this diagram, you have this x, this number underneath, we call it sub 1, y sub 1. All that means is that represents some point on the line. And they just happen to pick this point right here. And we don't know what the ordered pair actually is. We just know it's x and y. So we're going to call it x1, y1, or x sub 1, y sub 1. Then this one over here, notice it says x sub 2, y sub 2. All that means is that it's a different point other than the one with the 1. It's two different points that sit on the line. Okay, so that's what that notation means. So you have x sub 1 and y sub 1 are coordinates of point A, x sub 2, y sub 2 are the coordinates of point B. To find the slope of AB, you use the slope formula here. Okay, now again, this looks crazier than it really is. It's really not that hard. It just looks wild because we have all these letters in here. Okay, the slope, like we talked about earlier, it's the rise over the run. It's how much y changes divided by how much x changes. So over here, if you notice that this is y1 and this is y2. So if you were to subtract those 2 points, y2 minus y1, now remember y is a measure of up and down. You would have this distance from here to here. And that's what they're trying to say, that this distance between these 2 points is the difference in y2 minus y1. So you can actually calculate that by subtracting y sub 2 minus y sub 1. And all it means is you subtract the two y values. And then you do the same thing with the x values, and you put the x values on the bottom. Because the x values, when you subtract those 2 points right there, this x sub 2 minus this x sub 1, you're going to have this distance here. So we can actually figure out what the slope is without the graph, because sometimes I'm not going to give you the graph, and I'm going to give you hard points where you wouldn't be able to graph them. I might give you decimals or something like that. So you have to be able to take 2 points, use this idea, and find the slope. So it's important that you understand that the slope, now the letter M that I just drew right there, that is often stands for slope. Okay, so slope is found by subtracting the two y values and dividing it by the difference of the two x values, just like that. The only condition is that this does not end up equaling 0 when you're done, because you can't divide by 0. Okay, so number 13 says to find the change in the xy coordinates, you add or subtract. You subtract, that's what the change is. What number will you get in the denominator if the x coordinates are the same? If the x coordinates are the same. So they're saying if you have x sub 2 minus x sub 1 and they're the same numbers, what value would you have if you subtract the same number? You have 0. Explain how that will affect the answer you have for the slope. Well, you cannot divide by 0. Cannot divide by 0. Okay, so what we do with that is we say there is no slope in that case if you have 0 on the bottom, or we say it's undefined. You do not call that 0 slope. That's wrong. That's a whole different function, a whole different type of a line. Okay, moving on down the page, let's keep rolling here. What is the slope of the line through the points? 1, 3, and 4, negative 1. All right, it says you can use either pair for x sub 2, y sub 1, and complete the problem. Now, let's do this before we graph it, because you're going to have to, and all I have to do is make these numbers harder if I want to. So you need to understand how we use this formula to find the slope. Okay, now here they're trying to tell you right here that you can use either pair for x2, y2. It doesn't matter. It doesn't matter if it's the first or the second one, as long as you watch your signs carefully here. So what I did is I just called this one x1 and this one y1, and I called this one x2 and this one y2. All right, so using this formula, we take right here, we take y2 minus y1. Okay, here's y2. y2 is negative 1. So we put negative 1 right there. Then we put minus, okay, which they wrote in for you right there. Now this is y sub 1. It's negative 1 minus 3. Okay, see how I got that? Negative 1, y2 minus 3. In the denominator, okay, we take here, look back to that formula, x2, which is 4, minus 1. Now you do have to go back to the one you started with. If you do this as y2 first in your slope equation here, then you have to do the x sub 2 first. Now you subtract negative 1 minus 3, change it to addition, plus negative. Negative 1 plus negative 3 is negative 4. And then that's equals right there. 4 minus 1, that one we could probably do without changing it, okay. It's positive 3. Maybe I can't do it. So the slope of that line, the line that contains these 2 points, is negative 4 over 3. In other words, that means that y is changing 4 down 4, okay, as x is changing positive 3. So we can guess that the line is going to go probably go down that way because each point is going down 4 over 3, like that. And it says, now plot the points and draw a line through them. Does the slope of the line look as you expected it to? Well, we just said we think it's going to go down 4 because that's a negative number, and then it's go over 3 because that's a positive number. So we're going to guess that that line will probably go downhill that way. Let's check and see. Now they want us to plot it, so let's do that now. Okay, 1, 3, so plot that. Here's the origin over 1 up 3. 1, 2, 3. And then the second point is 4. Negative 1 is right there. Okay, so if we use the slope, or actually, now this is where you need your straight edge. So I can cheat because I can do this, but you need to grab a straight edge for this, and you need to connect that line with a straight edge and take pride in your work, please. All right, you also need arrows on both ends. All right, and there is the line that we just graphed. Now let's check the slope. Okay, 1, 2. Now I have these 2 points, so I'm going to drive the car from one point to the other. So I'm going to go down 1, 2, 3, 4. So I went down 4. Right, because that's my rise, the top number right there. That's the rise. Then I'm going to turn, and I'm going to go 1, 2, 3. I'm going to run 3 right there. So that is the slope of that line right there. So 16 says, does this look like you expected it to? Yes, it does, and we don't need to go on and explain because we've already discussed it right there. Okay, so with that said, let's look and see what happens if we have a horizontal or vertical line. And we can go through this one a little bit faster now. This one says, what is the slope of the line that goes through these 2 points? Let's see what happens, something strange here. 4, negative 3, so let's just go ahead and plot it. It says graph here first on 17. 4, negative 3 is right there. And then 4, 2 is right there. Okay, grab your straight edge, plot that line, connect that line right there. And I can move mine over a little bit. There we go. And I need to put an arrow on one end there. The arrow has to be there because it shows that the line actually continues forever. Is that line horizontal or vertical? Up and down is vertical. And it says, what is the slope of this line? Well, we can do it. We can just do it from the graph right here. Okay. All right. If I'm on this point right here and I'm going to this point, all right, I could go down or up actually. 1, 2, 3, 4, 5. I went down 5 and over 0. So my run is 0. Okay, so negative 5 is the rise. Okay, so negative 5 over 0. All right, that's no slope because the bottom number is 0. Okay, or we can say undefined. And if you recall from the previous chapter, we learned that that is actually not a function. So whenever that happens, you have a graph that's not a function. You cannot have two outputs for the same input, in this case at x is 4 there. So that's how we answer number 19 for us. So I'm going to stop this video and start another one, and hopefully I can wrap it up in one more video for you. We'll see.